Hello and welcome to the fourth video of the Introduction to IoT using NodeMCu video course. In this video, we will learn how to interface sensors like DHT11 and LM35 to the NodeMCu board. So let's get started. First, we'll talk about the DHT11 sensor. This is a temperature and humidity sensor. It senses the humidity and temperature of the room or the environment in which it is put and gives back a digital data. It has three pins, namely the VCC, ground and the data pin. Now, as you can see, this is the circuit diagram. Here you can see that the VCC pin is connected to the 3.3 voltage pin of the NodeMCu. The ground is connected to the ground pin of the NodeMCu and the data pin is connected to any of the 9 data pins available on the NodeMCu between D0 to D8. Now there can be two types of DHT11 sensors, one where you have 4 pins in which this pin remains unused and another with just 3 pins, that is the VCC, data pin and the ground. So this is the DHT11 sensor. As you can see, we have connected 3 jumper wires to it, the orange one to the VCC, the yellow one to the data pin and the green one to the ground pin. Now we are going to take the NodeMCu and we will connect this sensor to the board. So we have connected the VCC to the 3.3 volt, the ground to the ground pin of the NodeMCu and the data pin to the D6 pin of the NodeMCu. So now let's look at the code to run the DHT11 on the NodeMCu board. So open the Arduino IDE. For this code, you need the DHT11 library. So go on to Sketch, go to Include Library, go to Manage Libraries. Now search DHT11 and then install the DHT libraries from here. As you can see, it is already installed. In case it's not installed, select the version and then click on install and then close once it's installed. So now let's talk about the code. The first line hashtag include DHT.h means we are including the library of the DHT11. Next, we are going to define the type of DHT sensor that we are going to use in this program. In this case, we are using a DHT11 sensor. So we are defining the DHT type as DHT11. Next, we are defining DHT_D pin as D6, which means that whenever we use this DHT_D pin in the code, it will mean that the D6 pin of the NodeMCu is being used. Now in void setup, we are calling the function begin of the DHT class, which is included in the DHT library. Next, the serial.begin starts the serial monitor in which we can see the output of this DHT11, where we can see the temperature and the humidity, and the 9600 means the bandwidth, that is the number of bits transferred in a second. Now in the void loop part, we are defining two variables of the float type, that is h and t, which will read humidity and temperature from the DHT11 respectively. This read humidity and read temperature functions are already included in the DHT11 library. The following lines are for printing temperature and humidity on the serial monitor, and the last line delay of 1000. The 1000 stands for 1000 milliseconds, which means that the serial monitor will display the output at a delay of 1 second. Now we are going to connect the NodeMCu to the laptop using the USB cable, and we will upload the code to the NodeMCu board. Wait for it to get uploaded. Now as you can see, the done uploading message is flashed at the bottom of the screen. Now go to Tools and open the serial monitor. Now the humidity and the temperature recorded by the DHT11 sensor is displayed on the serial monitor. The next sensor we are going to talk about is LM35. This is a temperature sensor. It has 3 pins, namely Vout, Vs and the ground pin. Now this is the circuit diagram. As you can see, we are connecting the Vout to the analog pin of the NodeMCu, which means that the LM35 gives out analog output. The Vs is connected to the 3.3 voltage source of the NodeMCu, and the ground is connected to the ground pin of the NodeMCu. Now this is the LM35 sensor. The green jumper wire is connected to the ground pin. The yellow jumper wire is connected to the Vout or the analog output pin, and the orange jumper wire is connected to the Vs pin of the LM35 sensor. This is the final connection. The analog output pin of the LM35 sensor is connected to the A0 pin of the board. The Vs is connected to the 3.3 volt pin of the NodeMCu, and the ground pin of the sensor is connected to the ground pin of the NodeMCu. So let's discuss about the LM35 code a bit. First, we initialize or define the output pin of the LM35 temperature sensor by using an integer variable called output pin. Now in the void setup, we use a serial.begin to start the serial monitor. Now in the void loop, we declare an integer variable called analog value, and using the function analog read, we can obtain the analog output from the LM35 sensor. Now, the output from the A0 pin isn't the actual voltage value. The ADC divides its analog input range of 0 to 3.3 volt into 1024 discrete output values. It gives you a number between 0 to 1023, where 0 means 0 volt and 1023 means 3.3 volt. So to calculate the value, we are going to divide it by 1024 and then multiply it by 3300, which is the voltage provided by the NodeMCu in millivolt. Now we divide this millivolt value by 10 to obtain the temperature in Celsius and gradually print it. Now we can use the Fahrenheit to Celsius conversion to also print the temperature in Fahrenheit. Now we upload the code to the NodeMCu board. Wait for it to get uploaded. Now as you can see, the code is uploaded. So go on Tools, open the serial monitor. As you can see, the temperature is being displayed in Celsius and Fahrenheit. Now you can bring a hot or cold surface near the LM35 sensor to check the variation in temperature. Thank you for your patient listening. Please don't forget to like, share and subscribe to our channel for further videos on this course. Thank you.